Let me start with a question that sounds almost paradoxical. If scientific research drives medicine, technology, and economic growth, why do most university spin-offs fail to become meaningful businesses? Not slowly, not noisily, but quietly, repeatedly, and in almost the same way every time. This isn't a story about incompetence, and it isn't about bad intentions. Many of these companies are built on serious, rigorous science. So if the knowledge is real and the potential impact is real, what exactly is breaking between discovery and the market? Let's be clear about what this is not. This is not about bad research. Many university spin-offs are built on excellent science. The experiments are valid, the results are reproducible, the discoveries are real, and yet they still fail commercially. That tells us something important. When strong inputs consistently produce weak outcomes, the problem is rarely the inputs. It's the system they're being fed into. So the real explanation lives beneath the surface, in how value is actually created in markets. Here's a simple analogy. Oil is valuable, but oil underground is worth exactly $0. Value only appears after infrastructure exists. Pipelines, refineries, storage, distribution, markets. Knowledge works the same way. Research is not a product, it's a raw material. Most university spin-offs fail because they confuse discovery with delivery. They assume value transfers automatically. But markets don't reward raw materials. They reward finished goods, delivered through systems designed for adoption, not insight. Universities are extremely good at certain things. They are optimized to produce novelty, new discoveries at the edge of knowledge. They are optimized to publish proofs, rigorous validation through peer review. They advance understanding systematically. They train specialists deeply. These are not accidental strengths. They've been refined over centuries. But markets operate by very different rules. And excellence in one system does not automatically translate into effectiveness in another. Universities are not optimized for speed. Academic timelines run in years, not quarters. They are not optimized for market timing. Windows of opportunity can close while research continues. They are not optimized for customer discovery, especially when buyers and beneficiaries differ. And they are not optimized for operational risk, deployment, regulation, integration. So when universities create startups, they often export institutional assumptions into a world that runs on different rules. The result is familiar: companies that look impressive on paper and fragile in reality. Most university spin-offs don't fail in the lab. They don't even fail in early prototyping. They fail in what we can call the pipeline gap. The space between "this works scientifically" and "someone will pay to deploy this at scale." This gap includes regulation, procurement, integration, and deployment. It's where most commercial friction lives. Science validates truth. Markets validate coordination. The gap between them is where most spin-offs quietly stall. Once you look into the pipeline gap, a different set of questions appears. Who buys versus who uses? In many markets, they are not the same. Who pays versus who benefits? Value creation and value capture often diverge. How does this integrate with existing systems? Displacement requires compatibility, not superiority. What regulatory pathways exist? Approval timelines can exceed investor patience. Research rarely touches these questions. Markets are defined by them. Here's the uncomfortable truth. Everyone involved is acting rationally. Researchers are rewarded for publishing novelty and building reputation. Universities are rewarded for IP ownership, licensing potential, and innovation optics. Investors are rewarded for speed, traction, and clear customers. None of these incentives are wrong, but they don't align. And when incentives misalign, systems don't fail loudly. They fail predictably, through structure, not error. When these incentives collide, spin-offs enter the world carrying an inherited burden. Academic timelines, years of development before customer contact, legal rigidity, IP structures hardened before demand is proven, premature expectations of value, importance mistaken for readiness. These are not mistakes. They are predictable outcomes of incentives shaping behavior long before anyone notices the problem. By the time symptoms appear, the structure is already locked in. This is why failure looks the same across fields. You see a repeating signature, extensive building before buying behavior, legal and IP structures hardened before demand, technical performance optimized far beyond adoption, importance mistaken for urgency, academic validation prioritized over customer validation. These are not execution errors. They are predictable outcomes of academic systems colliding with markets. Different rules, different scorecards, same result. Markets don't adopt importance, they adopt displacement. Something must become cheaper, or safer, or faster, or mandatory, or institutionally unavoidable. Without at least one of these forces, nothing moves, no matter how scientifically impressive the research is. This isn't a judgment about quality. It's how coordination works when resources are limited and risk is real. We often explain spin-off failure by saying poor execution, lack of business skill, or insufficient funding. But what's actually happening is different. We keep releasing raw materials into a world that requires finished goods. The failure isn't intelligence, it's infrastructure. And infrastructure, the systems and incentives shaping outcomes, determines results long before anyone notices what's going wrong. This reframing matters. Because when failure is understood as structural, strategy changes. Different capabilities become visible. Capabilities universities aren't designed to build. Customer discovery, market timing, operational risk. And the answer stops being smarter researchers or better universities. It becomes better infrastructure, bridges between discovery and markets, not more brilliance, better coordination. This leads to a more uncomfortable question. If failure isn't about intelligence and it isn't about effort, why do the very traits that make someone successful in academia so often make them struggle in startups? In the next video, we'll explore what I call the Nobel Prize problem. Why the skills that win prestige in science can become liabilities in business. Not because anyone is wrong, but because they're playing a different game with the wrong scorecard. This video is part of Why Science Fails in Markets, a series produced by TaBIS. We examine how scientific truth collides with real-world incentives, institutions, and capital, and why so many brilliant ideas fail to scale. TaBIS studies the structural forces that determine which research reaches the world and which disappears quietly despite its merit. See you next time.